In this video tutorial we are going to look at using classes in processing to encapsulate all the capabilities of a particular idea. So what classes are all about: picking a particular concept and grouping everything that requires in one place. So we're going to do this by animating an ellipse and an orbit, and then look at animating multiple ellipses and how classes can benefit us here. The analogy that I like to think of this is declaring a class. Writing the actual class declaration is like forging a cookie cutter, and then using it in your programs is like cutting all these cookies. So you spend all this time crafting this one object, and it allows you to make many versions of it readily. So a similar setup has been familiar with so far for animating stuff. We've got a whole bunch of global variables at the top for a location, a diameter and an angle or trajectory, and a setup and draw function. So the first thing we're going to do is declare the size of the screen at 500 by 500, and then we're going to initialize the variables. So x is equal to width over 2, y equal to height over 2, d equal to intensity, and a equal to 0 at this point. So inside our draw function, whenever we're animating, we usually want to refresh the screen, so we're going to call background to do so here, and then we're going to draw our ellipse here at position x, y of width, diameter and height diameter. So in fact it's a circle. We can perturb the x and the y values to get the effect of animating just by using some increment operators. Let's see, we'll plus equals, so we'll add on to the y value 0.3 say. So it's going to increment 1 pixel each iteration in the x-axis and 0.3 of a pixel down the way. So we'll get the, what were we missing? Semicolon missing. Okay, so it's going in a linear fashion at a particular angle. So playing about with these increments for the x and the y is one way of making it move in a direction, but it's kind of tricky. I mean, that was maybe, I don't know, 15 degrees from horizontal or something, but it's hard to specify an angle in this fashion. So we can do it in a slightly simpler way by using x and y increments. X inc. And we're going to increment these using a little bit of trigonometry. So we're going to transfer our angle into an x component. So for the x one we use cosine. We need to convert from our angle in degrees to radians. So we do that using the radians function. And float y inc equals sine radians a for that. So if we want to move our object in this angle, 1 unit in that angle, these are the x and the y components that we need. So x plus equals x inc, y plus equals y inc. Okay. See if we've got any bugs here. Okay, so the angle is remaining fixed at 0, so it's not going in any direction. If we want to turn this into an orbit, we can just perturb this angle and increment it, so every iteration changes its heading slightly. So I can do that just by adding 1 to it, and we'll get a particular orbit. If I want to make it go in a even tighter orbit, I could add 2 to it and go in a smaller circular orbit. And we can play with the proportions of these components as well. So we could scale the x increment and the y increment. And if we scale the x increment by 2 and the y increment by 1, it will be a more elliptical orbit. Okay, but that's not what we're wanting to play with just now. Let's just imagine I want to generate 50 of these at random positions on the screen to produce something that looks kind of organic and natural. It's going to be quite problematic using this approach, so it's a really great candidate for using a class. So we'll do that by making our cookie cutter, or defining the class here, called bot, and we've got an uppercase B for bot because it's convention for classes to have an uppercase letter. We're going to just grab all these values, variables, and they become attributes in the class. The first thing that we need to write for the class is the constructor. And this is when we instantiate an object, when we create a class, when we hang something off our reference, this is what's called to kind of populate all these attributes. So in this case, it'll be called bot. It's the same, the constructor always has the exact same name as the class. We're going to pass this a bunch of floats. New x, float, new y, float, new d, and float, new a. Missing a space there. Perfect. So in here we're just going to, these arguments, these things that are passed to our new instance of bot are going to be used to set the value of the attributes. So x equals new x, and so on. And finally a equals new a. And just Control T that to tidy it up. So that's great, we've got our kind of skeleton of our class set up here. What we need to do now is we need to add some methods. We've got attributes and we've got the constructor to populate them with the or initialize them with the values we want. But we need some methods that embody and encapsulate what this thing's going to do. And the thing that it's going to do is move around in an orbit. So we'll have a function, or method rather, called void render. And we'll have another one, I think, called void update. And update is going to be responsible for updating the position of our bot. So let's just grab all that code from there and dump it in there. And render is going to be responsible for drawing our bot. Let's put the drawing code in there. And once we've created one of these objects, we are going to call these functions to update the position and to render. So we don't need this anymore. Grand. So we want a new object of type bot, we'll call it b1, and we'll initialize it in the setup function. We say b1 equals new bot, and this is the call to the constructor. So we need to make sure that we tell it all this information that it wants, and it wants 4 floating point numbers. So we want an x position, which we'll say random width, so some random position in the width axis, some random position in the height axis. The diameter, we'll do some random value between 0 and 10, and we'll maybe add 5 to that so it's not tiny. And the angle we can start as a random between 0 and 360. Okay. So if we run this just now, nothing's going to happen. It's just going to initialize this object and set all these values up. What we need to do is in our draw function, we need to call these methods to make it do what we want it to do. So we do b1, we use the dot operator to call a method in a class, and update first probably, to update the x and y values based on these, and then b1 dot render. Okay, let's see if that's going to work. Okay, so we've got a pretty massive diameter. Okay, we've got a wee typo here. I've made the diameter equals to new y. Should be equals to new d. Okay, that's a bit more like it. So it's very similar to what we had before. We seem to have done a lot more work to get this. But what it means is now that we've done this work, we can very simply manage having a lot of these. So if we simply change this to being an array, so we use the square brackets to say this bot thing, we don't just want a reference to one of them, we want a reference to what's going to be an array. We need to tell it how many elements we have. Like this, we'll have 50. Is that syntactically correct? That's the question. Yeah, it is. So because we've got 50 of them, we can't just call B1 anymore. We'll change it to B, in fact, that makes more sense. We need to put this inside a for loop to step through every instance we have and initialize it. So B1, we want a for loop. We're going to use the pointer I, which is just a variable, just an integer variable. We're going to do it while I is less than b.length, which is an attribute that an array has. It tells us how many elements it has, so we can be sure we don't move off the end of the array. We put it in the curly brackets and do Control T, and we change this to be I now. So what's going to happen is this loop is going to go around 50 times, and for every element we'll make a new bot with a random position, a random diameter and a random angle. We need to extend this code as well because we don't want B1 doesn't exist anymore. We need to have a loop which steps through every element of our array. Let's pop that in. Apple T. Use our square brackets again. Okay, brilliant. So now we should have a whole bunch of these things of different diameters. And one of the things that's kind of fun from this is we've created this really, really visually complicated thing. I mean, it looks like they're having some kind of interaction and have some knowledge about each other, the same with these ones. And it's not, it's just a whole bunch of orbiting things. And we've not really stepped up the variability much either. So if we want to make that even bigger, we can change this number to something bigger. Let's make that a variable. In fact, that would be good practice. Int bot count equals to 300. We can just go through and use this variable. Grand, that should be fine. Because we're using b.length, all of our arrays and stuff will step up to it. Cool. So there's something almost kind of sinister about that. So just to recap, what we did is we programmed one of these, not in a class, just using x, y values and such like as global variables up here. We initialized them in setup and we used the draw function, the body of the draw function, to update and render these things. We then decided it might be fun to have a whole bunch of these to produce something that looks complicated, and we thought the best way of doing that is to declare a class or a cookie cutter which encapsulates all these features. It has its attributes, its own wee local variable stored there that we can initialize to whatever we like, and it's got its two functions to update the position and render the thing. We then need to extend the way that our program works by declaring an array of these objects, initializing each reference in the array. So we've got 50 types, 50 things of type bot. We need to make them all equal to something, in this case something random, and then finally in our draw function we need to step through and update and render each of these. So hopefully that serves as a useful introduction and recap on how we can use classes in processing.